3.1, slope. Slope as a rate of change. Now, you spent all of grade 9 hearing about slope. Oh my goodness, we talked about slope so much. We're going to talk about slope again, but it's going to go faster. Okay, we're going to be done slope in about 2 days, maybe 1 day, so let's stay with this. Slope, first of all, is a very special mathematical word, and it means rate of change. And really what it means is we're going to have something change on the top, so change in something on the top, and we're going to call that y, and we're going to have change in something on the bottom, and we're going to call that x. So it's really, slope is a change in the y divided by the change in the x. And it's how quickly two things change in relative to each other. Key concepts. When the change in one variable relative to another variable is constant. So in other words, no matter how much I change one variable, the other variable changes a constant amount. The result is called a linear relation. That's what creates a line when we graph it. So a linear relation is something that looks like this, and you'll recognize this. Something in that form, y equals mx plus b, and we've talked about that so much. That's a linear relation. And the graph of this, or the picture of this, is a line. Now let's be very, very careful here. This is the relation. The algebra is the relation. And the picture is a line. They're two different things. They get different names. So this is the picture that it makes on a Cartesian plane. And this is the algebra. The algebra is a linear relation. The picture is a line. So, in a linear relation, the rate of change has a special name. It's called a slope. And for a linear relation, the slopes are all the same, no matter where you are on the line. A linear relation is the relationship between 2 points on a straight line. Slope measures the steepness. A way of talking about slope is to use this concept of steepness. The steeper the line, the greater the slope. Is one way that we talk about that. It's going to measure the rate of change of one point with respect to another point. And for every unit change in x, what we're really asking is, how much does y change? So again, we're saying, for every change in the x, how much does the y change? Now, I'm going to tell you something. People in science use slope an awful lot, and math, and they don't like writing out the word change. There's a symbol that they use for change, and it is a triangle. It's actually a Greek letter delta, but probably if you're taking science classes, you're going to start to see this, delta y over delta x. And it means the change in y divided by the change in x. It's not a triangle anymore. It's not short form for triangle because we're in a different unit. Different things mean different things in different math units. And this is used in science. So this is science talk for change. That's what that means. The other way that you're used to seeing this change written is in terms of y2 minus y1 over x2 minus x1. And again, I'm jumping ahead a little bit, and I'm bringing into things that you remember from grade 9, and that's where you took the y value of one point, subtract the y value from another point, and you divided it by the x value of one point, by the x value of another point. We're going to get into that. We're going to explain it. But do you remember seeing that last year? Yeah. Well, you should have. If you don't remember, then last year went pretty fast because we did that for a while. So do you remember seeing this? Rise over run. Okay. Well, these are the same thing. Rise over run. y2 minus y1 over x2 minus x1. delta y over delta x, change in y over change in x. And you know what all of that means? Slope. And you know what the short form for slope is? M. Don't ask me why it's an M. I have no idea why it's an M. That's the weirdest thing in my entire life that I figured out. But M stands for slope. All right, so let's continue. So I've jumped ahead here. Let's go back to the note. Let's talk about what rise is. Rise is the vertical distance between 2 points. Run is the horizontal distance between 2 points. So I think we can remember that rise is going up vertically and run is going horizontal. If you were to run away from a bear, and I went camping last weekend. So if I had to run away from a bear, I would run horizontally, right? And if I was rising as I went up the hill, I would be moving vertically. I think we can understand that. So rise is vertical, run is horizontal. So calculating slope. The variable used to represent slope is m, like I said up above. And again, I have no idea why it's m. There's not even an m in the whole word slope. Don't get it, don't understand it, oh well. To calculate slope, we're going to use an equation. Now, that equation I've already given to you is y2 minus y1 over x2 minus x1. That's the actual equation. So you're going to take the new y value, subtract an old y value, and you're going to divide that by a new x value, subtract the old x value. So let's see how this works. Here's a chart. We want to calculate the slope between these 2 points, m and n. So where is m and n? Not m and m, that's a wrapper, but between m to n. So we want to go from here to here. We want to know that slope. To do that, we need to know the difference in the rise and the run. So if we look at rise, rise is the vertical. Here's the vertical distance. Oh, I went too far. I went too far. There's the vertical distance. That is my rise. Here's my horizontal distance. That is my run. They make a 90-degree angle. So here's my run, here's my rise, to go from m to n. So my rise is how many units? Well, I started at 5, so I went 1, 2, 3, 4. It went up 4 units. And my run went 1, 2. It went over 2 units. So it went over 2 units. So my slope is going to be rise over run, which is 2 over 1. Or you could just write it as 2. But we need to remember that the 1's there to represent if I go over 1 distance, I go up 2 distance. Now, what did I just say there? Did I just say if I go over 1 distance? So this means over 1, and this means up 2. Now, this over, let me get this out of the way. This over is positive, so that means that we go to the right. And this 2 is positive, that means that we go up. So that means from any point on this line, since the slope is constant on a linear relation, and you should remember that, the slope is constant everywhere on this line, that if I started at this point, and if I went over 1 and go up 2, I should end up on the line again. And look at that, I do. Which means that if I was to pick another point, this point, and go over 1 and up 2, I should end up on the line again. That is what makes a line. The fact that the rate of change is constant. If the rate of change wasn't constant, it wouldn't line up as a line. It would be something else, like we're going to see in another unit. So, what if I wanted to do the slope between x and y? So here's x. Here's y. So I don't like doing my rise first. I really hate doing my rise first. I like doing my run first. I like starting here and going over 1, 2, 3, until I'm directly underneath what I need. So that means that my run is 3. And then I do my rise. I do 1, 2, 3, 4, 5, 6. I hate doing my rise first, and I just won't do it anymore. So I'm going to do my run, and then I'm going to do my rise. And notice that that makes a 90 degree. So slope is rise over run, so it's 6 over 3. Now, you do know how to reduce, right? I did this one up here sort of fast, but you know that 6 divided by 3 is 2. And the way that works is that 6 is 3 times 2 over 3, which means that the 3's reduce, giving you 2 over 1, which, oddly enough, is the exact same answer that we got above, meaning that this ratio, this slope, stayed the same. So what do you notice about the slopes of these segments? We notice that the slope of a line is constant. So the ratio of rise over run everywhere on this line, everywhere, will be equal to 2 over 1. Now if I don't go over 1, if I go over 2, how high should I go up? 4. If I don't go over 1, if I go over 5, how high should I go up? 10. Over 1, up 2. So if I go over 1, I go up 2. If I go over 2, I go up 4. If I go over 3, I go up 6. If I go over 4, I go up 8. If I go over 5, I go up 10. Okay? Do we see that? Okay, so this is constant. Now this formula up here, notice we didn't use it all. Maybe it would be nice if we used it and I showed you how to use it real quick. What are the coordinates of n? The coordinates of n are 5, 9. Do you agree? And what are the coordinates of m? The coordinates of m are 3, 5. Okay, so if I want to calculate the slope between n and m, then I'm going to pick one of them to be my first point, my other one to be my second point. That's up to you. I'm going to make this x2 and this y2. I'm going to make this x1 and I'm going to make this y1. Does that make sense? This is my second point. This is my first point. So the formula would look like this. 9 minus 5 over 5 minus 3, which is 4 over 2, which is 2 over 1. Oh my goodness, all of these are the same. This, this, this. Therefore, the slope of a line is always constant, and we can do it using this formula, or we can use the graph and count. Now that's a pretty quick review of grade 9, okay? But that's what we got to be able to do. Now, question. Do all lines have a slope of 2? No, just this one, right? And some others, but not all of them have a slope of 2. We have lots of different slopes. I'm going to pause the video there and we'll come right back.